I did a project with this stream modification that was done in 2008. And if you're not familiar with that project, they completely diverted the stream from where it was because of pollution, not having a riparian zone, which is where all of the grasses and the plants are. So in an attempt to increase the ecology of the area, the college financed a group called Wallace and Cancher, and they did a project on it, and they did a whole restoration. So we did a follow-up to a study that was done in 2006 before the restoration, and in 2006 they measured oxygen saturation, fecal coliform, pH, temperature, phosphates, nitrates, and turbidity. They also did a whole water quality index, which incorporates all of these factors into one index. And then they did the Hilsenhoff Biotic Index and the percent model affinity, which are two indices that deal with the macroinvertebrates in the stream. So in 2006, they saw that the water quality index was 92. And when we did a follow-up study in 2010, we found that it was 73. So all of the stuff that they had done to the stream didn't really improve the overall water quality index. So since it didn't improve the overall water quality index, we wondered if there was a significant difference between any of the factors that went into this indice. And we found that with an alpha of 0.05, none of our findings were significant. So we couldn't say that the stream restoration didn't improve the area, but we can't say that it improved it either. So we also did macroinvertebrate survey, and with that we did a Hilsenhoff Biotic Index, and the lower numbers indicate a better water quality. So you can see in 2006 the number was 3.93, and that's a pretty good number. It corresponds to a very good rating. And when we did it again in 2010, we got a 5.54 rating, which is only a fair rating. And we didn't recover as many macroinvertebrates as we had wanted to in 2010, and that could be because of the whole diverting of the stream that happened 2 years prior. And then we did percent model affinity, and in this one, higher numbers are better. And we found that in 2006, the number was 55, and in 2010 it was 50.5. And both of these indicate that the stream was slightly impacted by organic pollutants. But again, they were not significantly different, as you can see by the error bars, which are the standard deviation. So overall, we couldn't say that the stream modification actually improved the stream, which is kind of a shame. But from the literature that I found, in similar studies done in Finland and Ohio, they said that it would take up to 8 years for a stream to bounce back from a restoration like that, and we only did a study 2 years after. So what I suggest to do in the future for other freshwater biology classes is to do a follow-up study, maybe in 4 years, so it's been 6 years after the restoration, to see if this, all of the things that they had done actually did improve the health and quality of the stream.